Hello everyone. In this video, I would like to show you how to create a Scratch2 program that is equivalent to the Maneuver-1.sb2 file that you already have in chapter 3. So let me review it. So we have a start program. We set the variable called speed to 512. We set the delay time to half a second. We turn the port 1 clockwise at 512, port 2 counterclockwise 512. Essentially, this one make it go forward. We use the high resolution timer for half a second, and that's it. Okay. So what I'm going to do is I'm going to download this one to the controller. Let me show it here then. To show down the controller. So first I need to disconnect the Scratch so that the R+SCRATCH tool can connect to the controller and download this code now. So let's see if it's cooperating with me. Okay, so download it, and that's the code, and it turned itself off. So I'm going to just turn it back on again. Okay, so that's just maneuver 1. You see, I just basically go forward. And I want you to look carefully at the wheels, how it's turning. I hope you notice that they turn pretty much about the same time. It dragged a little bit to the left here. Okay, so this is the result of the task program. So right now the task program is on it right now. Okay, and if you remember from the previous video, as soon as I click on connect here, R+SCRATCH now is in control of the controller. And basically it just disabled that task program. So that task program won't be to run. Now everything that runs only accept command from the Scratch2 offline editor here. So let's create the little code equivalent to this. Let me put it up so I can refer to it as I create a code. So first we need to do is something like equivalent to start program. So where is that? In the event. There we go. So the equivalent for when the green flag is clicked, which is this, is referred to this green flag too. So that's the start program, equivalent to the start program. And remember the task program opened all the curly brackets for you. For us, now there's no such thing here. And then next we need to set the variable speed to 512, a variable called delay time to half a second. Okay. That we have to go to data. We're going to make a variable. We want all the sprites, so we want to call it speed. And if it by default it's checked, and then it will show up here. You want to see it, so by default 0. Okay. So next thing we need the delay time also. So we make another one. So we call that delay time. And there we go. Okay. All right. So you can see by default they're all 0 out. So the initial value. So we create those things. Let's see. So create the variable. So basically we just did the 2-step equivalent to here. Well, we actually create only the speed and the delay time. We haven't set it to 512 and 0.5 second yet. So that's the next thing we need to do on the program side, on the main script side. So we need to essentially set delay time to 0.5 and speed to 512 essentially. So we are here, so just drag it in. It happened to be delay time already there. So right click in this area, then left click in that area, just put in 0.5. And then pull another one in. Then we need to set up the speed now. Choose speed. And left click in there. We just enter in 512. Okay. So you notice it's equivalent to this. Speed is delay time on the left hand side of the assignment statement. And similarly, you can see it here. Okay. So next here we need to put the gear motor 1 count clockwise and plus speed. Okay. So how do we do that? That one, because it's a CM50 block, so we have to go here. And we're supposed to block 1 is clockwise, so it's clockwise already. And by default 512. So we need the speed. So we go to data and drag it out here and just drop it there. Okay. And then port 2 counterclockwise at speed also. So we go to more blocks. Make sure it's port 2 and it's counterclockwise. And once again, we draw the speed and drop it in there. So we're done with that. And then essentially here we need these two statements essentially make the computer controller wait for half a second. But we already have one. Let's see, wait here. So we just wait. We go back to data and drag delay time in there. So it's very important. You need to define all the variables you plan to use first before you trigger the statement. So now we're done. Now the interesting part is here. Remember, when the program on the controller itself using task, this program runs for essentially going forward for half a second, and then because it's the end of the program, the whole task program is exited. And you remember when when a program exited, a task program exited, the controller on the robot know how to turn everything off, power off, everything off. But here we have to make sure we do that extra step. Because when we give it to the command here, it's sent directly to the firmware over here. So if we don't tell it to turn it off, it won't stop. It keep on going even beyond half a second. So this is something different you have to remember when you use Scratch to make sure you complete the logic. So need 0, port 1 is 0. And then we'll also need port 2. Good. I clicked it wrong, it ran off. Oh, the video is not on, so you didn't see that one. So I made an error here. So it needs to be connected again, be sure. And this is kind of the danger because the program is live all the time. You have to make sure that you don't click in here and make it run. There you go, it went off again. Okay, you've all hit it. Let me make sure. Okay. That looks good there. All right. So we're connected. We finally finished the program. So now is right now is the Scratch offline editor is connected to the R+SCRATCH. The R+SCRATCH is in control of the CM50 controller right now. So we are pretty much ready to try our program out. When we're just gonna click here. Okay, I don't know if you noticed, but when I first start, it swings to the right a little bit, goes straight, and then swing to the left at the end. Shall we see it again? So please look carefully. Okay. Now let me run it again using the task program. If you remember, it's still on it. Okay. So I'm going to turn it off. Disconnect it here so that whatever I do, R+SCRATCH is not involved anymore. So when I turn it on, it's going to run the task program already built on it. Okay, you see it start on the left a little bit, but everything is going very evenly. The reason is because in the book we mention it because it takes time for the PC to go through the R+SCRATCH to read the controller itself. Port 1 essentially is about almost 80-90 millisecond going to run before port 2, and port 1 happened to be this one here. So at first run, this one turned on first, about 80 milliseconds before this one, so it's going to go like this, and then it goes straight, because both of them are turning now. At the end, this one is turned off about 80, 90 milliseconds first, so this stop, and this one is still running for some more, so it's going to go like this. Okay, so that's the reason why. Let me make sure everything connected back here. Connected, and then we run. Okay, you notice it goes zoop, and then accelerate, and then go straight and go zoop back again. So that's something you have to watch for when you create a program from scratch. Is there will be each of these takes a fair amount of time. It's because it has to go through this communication layer into the R+SCRATCH, and then from then to the robot itself. So that's something you need to watch out for.